again. So today we're going to be going over the quotient rule, and I'll write that here. Quotient rule for taking derivatives. So the quotient rule states that if I'm taking the derivative with respect to x of u over v, and it's important to know here that u and v are both functions, should be an equals there, are functions of x. So here's u, it's fx, and v is some other function, g of x, we just say g of x, some other function of x besides f. And so let's do this. So if we have d dx, u over v, where these two are functions, then the derivative of that by the quotient rule is going to be u prime, so the derivative of u times v, minus v prime times u. And that's all going to be divided by v squared. And I'll put a square or rectangle around this. And so that's the quotient rule. That's what the quotient rule states. And to make sense of this, let's work through an example real quick. So let's say we want to take the derivative with respect to x of x plus 6 over 3x. Well, first thing I would do is to apply this rule is to identify our function. So what is the top function u? That is x plus 6. And the bottom function v is 3x. Now plugging this into our equation here, our formula, we know that the derivative of this will equal u prime, so I'll go ahead and write this again. The derivative of x plus 6 over 3x will equal u prime, and I'll write this in derivative notation, d dx of x plus 6, and multiplied by v, which is 3x here, and minus the derivative with respect to x of v, so of 3x, and that's going to be multiplied by u, which is x plus 6. And I'll put a bracket here around this just to show that all of this here is subject to the distribution of this negative throughout it. And all of this, of course, is going to be over v squared, which is 3x squared. So let's evaluate these derivatives now. The derivative of x plus 6, well, the derivative of x is 1, and the derivative of 6, since it's a constant, is 0. And then multiplying that by 3x, and then there's a multiplication here, and then subtracting, and I'll keep the bracket here, the derivative of 3x, which is just going to be 3 times x plus 6. And all over 3x squared and 3 squared is 9. X squared is just simply x squared. And so let's combine these now. 1 plus 0 is 1 times 3x is 3x. Minus, that's going to be a negative 3 times x. Oh, got 2 minuses here. That will be a negative 3 times x, and a negative 3 times 6. Now that's 6, 12, 18. And over 9x squared. Now we'll notice here that we have a 3, and I'll just go ahead and do this here. We have a 3x minus itself. We know anything minus itself is 0, which just leaves us with a negative, I'll put 2 equals, which leaves us with a negative 18 on the top. And on the bottom, of course, we still have 9x squared. Now, this is the answer, but if you notice, a 9 goes both into 9, of course, once, and 18 twice. So this would equal negative 2 over 1, and then we have an x squared on the bottom. Now this is the answer. So we've done it, we've taken this derivative, but equal to this answer is also negative 2x to the negative 2, because the negative indicates that it's on the bottom of the denominator, and the 2 is just because it's squared. Now, this is also correct, but watch out for this. I've had professors who don't mind it being written like this. Most of them will want it written in this way, simply because when you write it like this, while it's correct, they might wonder if your knowledge of exponents is great enough that you'd realize that these two are equal. So most of the time, I would simply go with this one just to be safe. And so that's it. That's our derivative using the quotient rule. And I hope that helped. And I'll see you next time.